Hi, I'm Lance, and we're going to talk about how parts work in Flux today. In this tutorial, I'll cover using parts from the community library, the basic architecture of a part, and then exporting a bill of materials. So at Flux, we think a little differently about how parts should work. We're big believers in the power of open source. That means that anybody can publish a part to the community part library, which is searchable in the editor on the left here. So instead of having to start a project from scratch and do all the research yourself, there's a high likelihood that somebody else has already done that research, found the documentation, and has a well-defined part. So Flux allows you to build on top of the work of others. Let's do an example here. So let's search for ESP 8266, and you can see the results here. And let's just look at what we can see here. So the symbol on the left is what you're going to see when you drag the part onto the schematic. You see the title and description, the author of the part in green. You can actually click on that to go to their profile and see other schematics and parts that they've created. Then under that, we have a few metrics. So the first one on the left here is the usage count. That's the number of times that that part has been used in other people's projects. Next to that, we have stars, and that's the number of times that other people have starred this part. And you can actually star parts in the part search right here to save them to your profile. The stars are essentially a list of your favorite parts. The third thing you might want to look out for here is whether or not that part has a model. And you can see that with a little tag here that says model. This is really helpful if you're trying to create a simulated circuit. And you just want to make sure that you're selecting parts that have a model. That means they either have code or they have an internal schematic diagram that drives the function of that part. You can also create your own models or internal schematic diagrams, but we'll go into that in other tutorials. So let's talk about the information and metadata that's associated with a part. So I have a couple of examples here on the canvas. So if I click this resistor, I can see all the information about that resistor on the right here in this area called the inspector. So this is where you can see the symbol. You can modify the designator, view the part name, part description, fine-tune the schematic position. You can also control the part version here and choose between the head or latest. We have some more controls coming in soon that will basically notify you when there's updates and allow you to select whether or not you want to accept those updates. And you can always revert updates when you accept them. So don't worry about other people doing updates that mess up your work. You'll always have control. Then you can see the part author here and click to go to their profile and when it was created. Underneath that, you have states. And this is more for when you're doing simulation. You'll see metrics pop up there that show you the current state of that part. Also controls. I'll just go to this switch real quick so you can see that. So when there are controls, this is where you can access them. You can modify a switch to be open or close, things like that, push button, whatever it might be, sliders. And then properties. So we have a few default properties, and then we allow users to add as many properties as they want. And this is really helpful if people want to add links to examples or videos or more documentation, reference schematic diagrams, whatever it might be. But rest assured, all the basics should be here. So physical properties like resistance, the category of that part, power rating, designator prefix, manufacturer part number, name, the package, case code, or a datasheet URL. So there's a lot of information that can be associated with a part. And all of this is exported when you export the bill of materials, which I'll show later. And so something that's really important to understand how parts work in Flux is this concept of nesting. So I'm going to use this low noise amplifier as an example. So I can actually go inside a part. I'm just going to hit open and go here. So now I'm inside a part, the low noise amplifier, and looking at its internal schematic diagram. You can see the pins relate to the pins that I have in my schematic when I'm looking at the part. So you can see signal in, ground, and then RF out with DC. So that relates to, if I go back here, signal in, over here, ground, and RF out with DC. So you can understand like that's a pretty powerful thing. You can actually nest parts and schematics like within each other. So you can think of a schematic kind of like a subroutine in software, if you like to work like that. And this schematic diagram also drives the function of that part in a simulation. So you can either have the schematic diagram drive the function of a part in simulation, or you can actually program the simulator code yourself. I'll show you an example for that. So if I open up this resistor, I'm going to see two pins here, P1 and P2, which makes sense because it's just a resistor. And then I can look at the code that runs that resistor inside. But we'll get into this in future tutorials. So a note on forking parts. So for most of the parts in the community library, you'll have view-only control. And that allows you to modify things like the designator and physical properties. But if you want to edit anything more substantial, then you'll need to fork that part. And this is really helpful if you don't want to create a part from scratch. You can just select, an existing part like this resistor. You would open it up. So now I have the resistor open, and then I just click fork here. And now I can name this part whatever I want. I can call it Lance's resistor. And now I can modify the properties by hitting edit here, changing the order. Basically, I have full control over that part now, and I can publish that updated version to the community part library as well. So that's pretty cool. The last thing I'll cover is exporting a bill of materials. So once you've built your schematic, and you might want to export your BOM so that you can source parts wherever you like to source parts. And to do that, you just click the hamburger menu at the top left here, go to the row export, and then click bill of materials. So that'll export a CSV in a common format that you can upload to most suppliers to source your parts. So that's it. We covered using parts from the community part library, the architecture of a part, and how to export your BOM. Thanks.